you have more control over that thing if you press harder. I can tell
Okay.
you're not pressing very hard because your writing is, the color is so pale.
Okay.
And it feels
5,
better.
there we go, plus square root of 4 plus x. Okay, so I know x cannot equal -4. You know that?
Why not?
Because that means it'd be the square root of 0.
Does the square root of 0 exist?
Yeah, it does.
No. Oh, it does? Oh.
Yeah.
Yes.
It's
Square root
just
of 0 is 0. However, you're on the right track. You're thinking along the right lines. I can put x equals -4 in there. Can I put in x equals -4.1?
No.
Why not?
Because you'd have to take the square root of a negative.
That's right.
you can't take the
Okay.
square root of a negative.
So x is all real numbers greater than or equal to -4. Onward.
Good.
Like
So,
from-
okay.
here's
Now,
the-
the question that you just answered there, is that the domain or the range?
That is the range.
Domain.
the
No, that is
domain.
it.
That is
Wait.
the domain. Okay, which is a perfectly good question to ask. So first, let's write down our domain. Now, Cooper said it's all x's bigger than or equal to -4. So, how would you write that in?
So it's all x's, what is it again? So
He
all
said bigger than or equal to -4. So we want to use some interval notation to indicate all of the numbers from -4 on. Good. Square bracket. Perfect. Infinity. Okay, good. Now, let's think about the range. So the range is asking a completely different question. It's not asking what am I allowed to put in, but what could I possibly get out? Now, whenever you see a square root in a function, it is talking about only the positive square roots, because once you start talking about both positive and negative functions, or negative square roots, those exist, but it makes it not a function anymore.
Yeah.
Right? The rule about a function is it has to give you one and only one value. So when you see the square root, they're automatically talking about the positive square root, which means that when I have this in here, I'm only getting positive values out, positive or 0, because I can get, if I plug -4 in, I will get 0. So, what do you know about every number that this function spits out?
Positive.
It's definitely positive, and
It'd be 5 or greater?
it would be 5 or greater, exactly.
Okay. So that means it would be 5, comma, infinity.
Good, excellent. Now, what I want you to do is pull up the graphing calculator and graph that function and verify with a picture that that is correct.
How do I go to the, there we go.
It's this one over here.
Okay, so I'm going to graph it.
I think it's not
Oh,
long.
it's
That's so weird that it like
I bet whoever programmed this was like, it's going to be so realistic.
it even turns off.
Wait, is that
You know what,
life size?
Try to keep it in the yellow,
right.
yeah.
Like,
there.
is that life size, Lily? Nah.
Well, no, because this one's smaller than the one that's up there. It's
But that one's life
That's a bigger
size.
screen.
could be, but if we change the monitor size, it would get even bigger.
So if we had
Okay.
a huge projector, we'll be like the
Yeah,
biggest
yeah. I don't
calculator.
have a projector, but
Five
it's so bad.
plus
Like,
Useless.
square root of 4 minus.
is it 4 minus x or 4 plus x?
4.
It's 4 minus x.
Well, we worked
Ah,
4
we
plus
were
x,
doing 4
so
plus
do that
x.
one.
4 plus. Oops. Okay. And then
Do yeah, we've got some, we were making crazy windows in calculus, so do zoom 6, just to go back to the standard -10 to 10 window.
aha.
Okay, so now, first of all, what's going on the left side of this graph? Why is it just like start in the middle of nowhere?
Because that's where the restriction is.
Yes, right. We have for x smaller than that value, -4, there is no.
There is
It's
none.
undefined, so that's why there's nothing over there. All right, and then go ahead and go to the window button, and let's make x maximum 100, and make the y maximum 17. Okay, So that's not a particularly large y maximum, but you can see that as we extend our window, our function is continuing slowly, but it is continuing to go up. So we'd have to put in huge x values to get big y values because we're square rooting things, which automatically makes them smaller. But you can see we start off at 5 and we go up to infinity on the y-axis in terms of our range values.
So the graphing's like a way to check it.
Yes.
Almost.
Yes, it is. It's an excellent way to check it if you have been able to do it, kind of reasoning it out. It's also, there's going to be a lot of problems that that'll be your first tool to kind of narrow down what the range might be. Draw the picture, and you'll see some things in it, and you'll go, oh, I know why that's happening. It's because I have a square root, or I have a square, or I have a exponential function, or something